Spacecraft that enter or exit the atmosphere inherently encounter a hypersonic flight regime. Really navigating the challenges of hypersonics and flying in that way involves solving a lot of new and difficult engineering problems to achieve that type of flight. The vehicle is actually going so fast that the air in front of it doesn't have time to get out of the way. So you might go from a temperature of 200 degrees centigrade to 20,000 degrees centigrade within that shock wave. When you heat air to that type of temperature, it ceases to become air as we know it, only oxygen and nitrogen, but it instead starts to chemically react and it starts to dissociate. It may even form a plasma. Plasma may experience effects due to electric and magnetic fields because it is electrically conductive. So now an individual plasma particle may experience forces due to, yes, collisions between themselves or the wall, but also these bulk field effects. And that opens up a lot of interesting avenues for maybe being able to control the flow with those electric and magnetic fields. We are trying to primarily replicate the heating environment. We take a lot of power and we concentrate it into a plasma beam. And then what we do is we might get a coupon or a test article of some representative sample from a hypersonic vehicle. And then we actually insert that into the flow and then we observe what happens to it. So if it's a heating test, we might be measuring the temperature, we might be measuring the heat flux, we might be measuring the time until failure. It's about improving access to space. It's also about improving our knowledge as a species. So a lot of planetary exploration missions, when we send probes to other planets like Mars or Venus, we have to go through their atmosphere. And we have to provide mission assurance and safety for that science payload. And reentry remains a very dangerous phase of those missions, and so a lot of research goes on, both theoretical, computational, and in the end, experimental to qualify and prove those systems to enable us to explore the solar system.